Well, I pulled the bolt out of here and the key fell out, so that does not bode well. Well, there's your problem. The whole armature of this motor is supposed to be welded to the end of that shaft. Yep, that's not good. Shaft snapped off there. That's supposed to go on there and get sandwiched on that. Bad times. Bad times. This motor is one of the original drive motors I had from version 1 and 2 of the electric zero turn. It had a gearbox on this side, the gear reduction, and then this would go out to the chain to drive the wheels. So I stripped everything off of it. There was a fan that came out of this side. I'll pull it apart in a minute and I'll show you that. But the shaft of the motor went through. There's a key through it, and the rotor gets pressed on there with the keyway, and that's what turns this. So I machined a new shaft that had the key in it, and then I put a spacer in here because I didn't have the right bearing size. I'll get the right bearing eventually. But that's how big the shaft is with the key. So I had to make a, like I said, a little bushing in there. And then the shaft goes through and is threaded for the blade. I made this with a 1-inch stock when I had a smaller blade, but for the 54-inch Hustler. But on the Deer, the bore on here is bigger, so it barely seats on there. I had a little 3D printed spacer just to get it centered while I bolted it together. Can't even get it off. Anyway, just goes in there. So I set this up for testing. I've just got the 3D printed adapter on the bottom of it. It works, but I think there's too much flex in it, so it does vibrate when you're mowing, but the blade's on it right now and the other two are disconnected, so it's just the one. So let's do it. Maybe not. Oh yeah, safety. Everything's got to be off when you turn it on. Okay, test this again. It works, but when there's a load on the blade, I think it's flexing the plate. So I think I'm gonna have to make it out of steel, which is not shocking. But it does work, so we'll give her a shot. So this is what it looks like. That's the bushing that I made for that bearing down there. And then that's the shaft I machined. It's got the keyway in it. Goes through a bearing in there. 3D printed housing for now. Eventually gonna have to be made out of steel, and then shaft. New shaft is gonna be made out of 1.5 inch, 1144. Here's some clips to it being machined. Well, this is pressing the rotor off of the drive shaft because I need to remake it. Using brass to push that through there so it doesn't get magnetized to these. These are all the magnets right around here. I put tape on them every time I take them off because it gets dust and magnetic dust and shit all over it. Not unexpectedly, this broke trying to get this off. This bearing was a pretty good press fit in there. So anyway, it snapped off, whatever, just plastic. Takes a couple hours to reprint it. This is the shaft that I had machined before with that keyway in there that I'm reproducing now, only instead of 1 inch, 1.5 inches. And then keep all the metal away from that thing because that thing is strong. There's a shaft in there, I just know it. Just have to machine it out. Because this is just a little tiny hobby lathe, I'm turning it between centers. I can't get it that repeatable with this piece of junk chuck, but whatever. I cut a center on that piece that's in there to hold that end, and then I've got a live center on that end. If it's stupid but it works, it's not stupid, right? All right. There we go. Framing. Ta-da! Tapping the thread for the spindle bolt. Why not just get the fucking stool? It's so damn short. This is way better. Tried to take a video of milling the keyway, but it's too shaky, so it happened. Pressing on the rotor. Alright, this is where we're leaving it for now because I'm still waiting on the bearing to go here. It goes in the cap. So, 1.5 round bar, machine down, 2 steps, one there, one here for this bearing press fit. Just cleaned up this OD. Register for the blade down here, tapped and threaded for 5/8 11 for the bolt that goes in the mower blade, and the little spring washer, if you want to call it that. Anyway, milled keyway for the rotor in there, and that's just the center. So it should all assemble. I have this bearing cap that I 3D printed because this was the prototype. This was the one that I had put on and mowed a little bit with, but when I was taking it off, the bearing fit was too tight and it broke this off. So I'm thinking about, this is ABS glass fiber, so it's good for over 100 Celsius, which is hotter than the motor can get. So I thought about just printing this just as a locating, and then basically making a flat piece of steel with the hole patterns in it and just bolting the motor to this with the bearing locator in the bottom. So it basically would be this, 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 and then this whole assembly would get bolted onto a piece of metal that looked like that through those holes right there. And then it would bolt onto the mower, obviously. Anyway, it worked with the 3D printed adapter, so it should work with steel. Thanks for watching.